In this video, we're going to get some practice finding explicit formulas for sequences once we're given a few terms of the sequence. And we want to be on the lookout for things that we saw in the last video. We saw lots of n raised to a power. We saw n factorial. We saw numbers times n. We saw -1 raised to the n. We saw all different kinds of tools that we can try to think about when we're creating the sequence. All right, so this one tells us we've got all these fractions in here, and we want to keep in mind what the index of each term is. So we know that for this one, n needs to be 1, n needs to be 2, n needs to be 3, n needs to be 4. So we're going to kind of keep in mind what can we do with that n value to create each fraction. All right, and if you have fractions, it's often useful to think about the numerator and the denominator separately. So if I look at those numerators, 1, 4, 9, 16, I'm going to recognize those as the perfect squares. All right, and those are just the squares of what our index is, right? If I take my green numbers and square them, I get the numerator in the fraction. All right, so that's going to be my first step, is to say it looks like we're putting n squared up into the numerator. In the denominator, we've got 25, 125, 625, 3125. We saw 25 and 125 in the last video. Obviously, 25 is 5 squared, but we saw 125, that was 5 cubed. So I'm a little suspicious that I've got powers of 5 in the denominator. So let's see if 625 is 5 to the 4th. Just check on my calculator real quick. 5 to the 4th, 625, and then 5 to the 5th is 3125. Okay, so I've got 5 squared, 5 cubed, 5 to the 4th, and 5 to the 5th. So that's not exactly 5 to the n. I'm kind of off 1 power, all right? I actually want 1 more power than the n that I have. When n is 1, I want 5 squared. When n is 2, I want it cubed. When n is 3, I want it to the 4th. So in the denominator here, we're going to have 5, not to the n, but to the n plus 1. And that takes care of everything that they've given us in this sequence. This looks like a good explicit formula. This sequence is an alternating sequence. Remember, those are the ones that alternate between positive and negative. And we saw in the last video that that can be created by a -1 to the n. Sometimes it has to be something other than n, but we'll kind of keep that in our back pocket, that we want -1 to the something so that we get that positive negative alternating throughout the sequence. The first thing that I'm going to do here is try to write the first 2 terms as a fraction. It seems like I've got lots of fractions going on in the 3rd, 4th, and 5th terms. So I'm going to see if I can try to write in a pattern kind of way these first 2 terms as fractions that kind of follow what's going on. All right, so the last 3 terms have 4, 5, and 6 in the numerator. So I'm going to hope that I can write this as a fraction with a 3 and a 2. And I need to make sure that that second term is negative. All right, so if I do that, I want this fraction to be equal to -1. So I'd better put a 3 in the denominator, and 2, I want that still to be 2, so that one needs a 1 in the denominator. And hopefully this is going to be helpful to recognize a pattern. All right, so the numerators are just 2, 3, 4, 5, 6. That's a clear pattern. And now the denominators we can see are the odd numbers. And we learned a formula for coming up with odd numbers. All right, so let's just keep track of our indices. We've got n equals 1, n equals 2, n equals 3, 4, and 5. So it looks like those numerators are always 1 more than the index. All right, so I'm going to write that down first. I know I'm going to have a -1 to the something here to keep track of that alternating part of the sequence. We'll come back and worry about the exponent in a minute. And then the numerator, I said we're going to put n plus 1 on top. On the bottom, we've got those odd numbers, and we saw those can either be something like 2n plus 1, 2n minus 1. It just has to be an even sequence, 2n, and then plus 1, minus 1, plus 3, minus 3. Any odd number that you add or subtract to the even numbers is going to give you a sequence of odd numbers. So let's just see which one works for 1, 3, 5, 7, 9. Looks like 2n minus 1 is going to do it. So when I plug in 2 times 1, I get 1. When I plug in 2 times 2, I get 3. And that's what I want, right? The 1, 3, 5, 7, 9. So I want 2n minus 1. So that takes care of the numbers in my sequence. I need to make sure that I get the right alternating positive, negative, negative, positive going on in the sequence. So in the last video, our alternating sequence was caused by a -1 to the n. Right? -1 to the n, though, starts off at n equals 1, giving you a negative term. And then n equals 2 gives you the positive term. So if I leave it -1 to the n, that would create a sequence that went negative, positive, starting off with a negative. And we want it to start off with the positive. All right, so all we need to do is shift that number over one so that we start off with a square, or maybe even a 0 would work. All right, so I want to start off with this square at n equals 1. Right, so I need to take that exponent n and add one more to it so that whenever we're at an even term, it goes to an odd exponent. Wherever we're at an odd term, it'll go to an even exponent. All right, and that actually gives us the same exponent as the number in the numerator. So in all these terms where we have an even number in the numerator, we're going to have an even exponent on that -1, which is going to give us the positive term that we want.